Jai Shri friends. Today we shall start chapter number 7, which is gravitation, with lecture number 45. Topics are gravity versus gravitation. Second is acceleration due to gravity, and then finally we shall discuss about Newton's universal law of gravitation. Let us start. First of all, let us see what is the meaning of gravitation. See, every body in the universe attracts every other body with a force which is called force of gravitation. Okay. Thus, gravitation is a force of attraction between any two bodies in the universe, you can say. Similarly, you can see the example of this. What is the example of this? The attraction between the sun and earth, or you can say the attraction between a table and a chair lying in a room, etc. Now come to gravity. Gravity is a special case of gravitation. If one of the attracting bodies is the earth, then gravitation is called gravity. So gravity is nothing but the force of attraction between the earth and any object lying on or near its surface. For example, the body thrown up falls back on the surface of the earth due to the earth's force of gravity. We can say there are forces of attraction between these two. Okay, like this. These are the forces. Similarly, in this case also, there is a force of attraction between the two, you can say. Okay, so this is the difference between gravitation and gravity. Now, second topic is what is free fall? As you can say, what is the meaning of free fall? Motion of a body under the influence of gravity alone is called a free fall. As you can see from this diagram, so a body falls freely only in the vacuum. The motion of a small heavy body in air may be taken as a free fall because air resistance on it is very small, right? Now, next one is the acceleration due to gravity. Now, what is the meaning of acceleration? Rate of change of velocity. Okay. Now, here you can refer this diagram in which a body is attracted toward the earth due to the gravity. So, the acceleration produced is in a freely body, falling body under the gravitational pull on the earth is called acceleration due to gravity. Okay. Now, see, it is a vector having direction toward the earth of the center of the earth. Second thing, it does not depend on the mass, size, and the shape of the body. Then the value of g is constant at a given place. Similarly, how it varies from place to place on the surface of the earth. And finally, it depends on the altitude, depth, rotation of the earth, and the shape of the earth. So these are certain points about the gravitation. Now, body weight. What is the meaning of body weight? As you can see in this diagram, this is say gravitation, gravity of earth. So weight is weight of a body is defined as the gravitational force with which a body is attracted towards the center of the earth. Okay, right? So this is one thing. Now, similarly, you can say the formula, you can say W is equal to m into g. This is the expression. Means W the weight and mass of the body is m and g is the gravity constant. So weight of is again a vector quantity. As the value of g varies from place to place, the weight of the body also varies from place to place. Okay. So here I can say that this one g. So you can say this W is equal to mg. W is equal to mg, which is also equal to f. Okay. Now see what is Newton's law of gravitation. As you can see, there are two particles of mass m1 and m2 at certain distance r, which is having force of attraction. As I've just told you, what is the force of attraction? So this is force which is equal force of attraction on both the sides. So every particle in the universe attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distances between them. This force acts along the line joining the two particles. आप देख रहे हैं लाइन join कर रही है तो F is proportional to m1 m2 and secondly F is proportional to 1 upon r square. So finally if you are combining, this results in F proportional to m1 into m2 upon r square. So this, if constant of proportionality is put here, then equation becomes F is equal to g m1 m2 upon r square, where g is called universal gravitational constant and the value of g is 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. Okay, now how would you define g? So let us define g also, right? This F is equal to g m1 m2 upon n square, as we have already seen. So if m1 is equal to m2 is equal to 1 and this r is equal to 1, means the distance between the two particles is 1 and both the particles are having unity mass, then F is equal to g. So the universal gravitation constant may be defined as the force of attraction between two bodies of unit mass each and placed unit distance apart. So this is the basic definition of g, which is universal gravitation constant. SI unit is nothing but Newton meter square per kilogram square, and dimensions की जहां तक बात है, it is m-1 L cube t की power -2 and g is equal to 6.67 into 10 raised to power -11 Newton meter square per kilometer square. So this is about today's lecture. नेक्स्ट लेक्चर में आपसे फिर मिलता हूं दोस्तों, तब तक के लिए जय श्री सीताराम जी.